So this is the third kind of numerical problem on uh, different empirical equation for estimating peak flood. Okay. So here the question is estimate peak flood or peak discharge QP in meter cube per second with the help of different empirical equation based on the location of the watershed. Here the area of the watershed and the location of the watershed. Area and location of watershed is given. You have to find the Q. You see, estimate maximum flood flow, or this is also known as QP, peak discharge, in meter cube per second, using appropriate empirical formula. As you know that there are various different empirical formula developed for the watersheds located at different parts of India. For example, English formula is developed for the watershed of Western Ghats in Maharashtra. Nowadays it is also used for other watersheds in Maharashtra, but this formula is developed for the Maharashtrian region. Similarly, Dickens formula, this formula is developed for the watersheds of central and northern parts of the country. And Wright's formula, this formula was developed for the southern watershed of the southern states like Tamil Nadu, and later on it is developed for Karnataka and Andhra Pradesh also. Now this problem states that the area of the watersheds are given, the location of the watersheds are given. You have to estimate peak flood using the appropriate empirical formula available or developed for that for those regions. Now, as you see, which formula is developed for Maharashtra. So you see the first watershed is located in Maharashtra. So for this we will use English formula. So there will be no H, there will be only S, English. So this English or English. So this English formula will be used for the watershed located in the state of Maharashtra. Then in the second watershed, the area is same, but it is located in the Gangetic Plains. Gangetic Plain means northern part of India. Gangetic Plain means northern part of India. So here we will use the Dickens formula. As it is northern part, so we will use Dickens. Now, third one is this watershed also has the same area. However, this watershed is located in the Kaveri Delta. Kaveri Delta is in southern part, Tamil Nadu region. So we will use the Wright's formula. Because as you see, Wright's formula is developed for the southern region, Dickens for the north and central region, and English formula for the western Ghats. Okay. So here you see what is the English formula. Let us see. English formula is QP. QP is the peak flood or maximum flood or peak discharge in meter cube per second. This is area in kilometer square. This 124, 10.4 are empirical constants, and this is A is also the area. Now, the area of the watershed is given 40.5 square kilometer. all these area are given in square kilometer. So if you just put 40.5 in place of A, just put 40.5 in place of A, then the equation will be like this. Okay, and if you calculate this, it will come 704 meter cube per second. Remember, all these QP are in meter cube per second, so we have to calculate it in meter cube per second. So if you calculate this one, then you will get the result 704 meter cube per second. It is simple arithmetic calculation, so I am not discussing, elaborating it further. Now for the watershed in the Gangetic Plain, that means the northern part of the India, we have used Dickens formula. So the Dickens formula is QP is equal to CD into A to the power 3 by 4. Here A is our watershed area in kilometers square. CD is actually the Dickens constant. There you see, CD is the Dickens constant. Now Dickens constant is different for the watershed located in different regions of north and central. For example, you see this, if the watershed is located in the North Indian plains, then the value of CD will be this 6. If it is located in the North Indian hilly region, then the value of CD will be 11 to 14. If it is located, the watershed is located in the central India, then the value will be 14 to 28. If the watersheds are located in coastal Andhra and Odisha, then it is 22 to 28. All these terms are unitless, mind it. Discharge constant does not have any units. So here also it is very simple. They have said it is located in the Gangetic Plain. So we will use North Indian plains. The value of CD for North Indian plains, as our watershed is located in the Gangetic plains, and Gangetic plains come under the North Indian plains. So the constant is 6. We select 6 as CD. So this equation becomes QB. This equation becomes QB equals to CD is 6, area is 40.5 square kilometer to the power 3 by, area is this 40.5 to the power 3 by. Now if you calculate this, then it will come as 96.3 meter cube per second. This will come as 96.3 meter cube per second. So what we have done is, in case of Dickens formula, we have put the value of area A, we have put the value of CD, the Dickens constant, as 6, as the watershed is located in the Gangetic Plain, and Dickens constant for North Indian plains is 6. That can be derived from the table, given table. This table will also be given to you in the problems. So this will be 6. So the equation is like this: the product of CD and area to the power 3 by 4. So 6 into 40.5 to the power 3 by 4 is 96.3 meter cube per second. So this is how we use the Dickens formula. Now let us say third one, the Kaveri Delta. Watershed is located in the Kaveri Delta. Area is same 40.5. So Wright's formula is developed for the watersheds located in the Tamil Nadu, Karnataka and Andhra Pradesh. So southern states, Kaveri Delta is located in the southern states. So what we have done is, and this Kaveri Delta is within 80 kilometers from the east coast. So that is why we have taken 6.8. So in case of the last, we will take the value of CR. CR means Wright's coefficient at 6.8, as Kaveri Delta is located within 80 kilometers from the east coast. Okay. So CR will be 6.8. Now this formula, Rice formula is what? It states that QP, peak flow or maximum flood flow or peak discharge is in meter cube per second is equals to Wright's coefficient multiplied by A to the power 2 by 3. Here A is your 40.5 km square. CR we have taken as 6.8, as Kaveri Delta, the watershed is located in Kaveri Delta, and Kaveri Delta is located within 80 km from the east coast. So 6.8 is the constant or CR. So put the values similarly, 6.8 multiplied by 20.5 km square by 2 by 3. Okay, so this will come as 80.2 meter cube per second. 80.2 meter cube per second. So overall, this is the way you have to use the empirical equation developed for the watersheds located in different regions of India. As you see that you have been given three watersheds. Area is same for all these three watersheds, but the watersheds are located in different regions of India. One is located in Maharashtra, one is located in Gangetic Plain, another one is located in Kaveri Delta. Now we have English formula for the watersheds of Maharashtra. The empirical formula was developed for the watersheds of Maharashtra. So we will use, for the first case, we will use English formula as the watershed is located in Ghat area of Maharashtra. So for the second case, the watershed is located in Gangetic Plain, that is northern part of India, and that is also the North Indian plains. So we will use the Dickens formula, as Dickens formula was developed for the watershed of central and northern parts of the country. So Dickens formula is QP equals to CD multiplied by A to the power 3 by 4, where the CD is also determined based on the location of the watershed within the north and central Indian region. So here you can see this table is giving you the values of CD based on the location of watershed. So for North Indian plains, as Gangetic Plain is located in North Indian plains, value of CD will be 6. That is why we will put CD as 6 in this case. Area is 40.5. So QB will be 6 multiplied by 40.5 to the power 3 by 4. This will come as 96.3 meter cube per second. And for the last case, for the last watershed, the third one is located in Kaveri Delta. Kaveri Delta is located in the southern part of the India. And for southern part, we have Rice formula. So we use the Rice formula. The Rice formula is also QP is equals to CR, Rice coefficient, multiplied by area to the power 2 by 3. So here also CR is determined based on the location of watershed, and these the values of CR is given here, as you can see. As Kaveri Delta is located within 80 km from the east coast, so we have taken the value of CR at 6.8. So if I put the value of CR at 6.8, area I know that this is 40.5. So the QP, the peak flood or maximum flood flow or peak discharge, QP will be equals to CR multiplied by 8 to the power 2 by 3. CR is 6.8, A is 40.5 to the power 2 by 3. It will come as 80.2 meter cube per second. So this is the way you have to calculate this QP, maximum flood flow, or it is also said as peak flood, or it is also said as whatever way you refer this as, but you can use the empirical formula developed for the different regions of Indian watersheds. So, but the only thing is you have to select the empirical equation as per the location of the watershed. And also you have to select the value of the discharge CD and CR. That means CD is your Dickens constant and CR is your Rives coefficient. So value of this Rives coefficient or Dickens constant is also based on the location of the watershed. So you have to select the coefficients accordingly and put those values into your empirical formulas developed for the watershed of those regions, and then you will get the. So note that English formula was developed for Maharashtrian watersheds. Dickens formula is developed for the watersheds of central and northern parts of India, and Rice formula was developed for the watersheds of Tamil Nadu and later for Karnataka and Andhra Pradesh. So these three formulas are very old formula. It was developed in the 19th century. So, but they are still now they are used for calculating peak flood in different design